Okay, so this tutorial concerns something called orders of reaction. Okay, so really it's all about rate. Okay, now we've looked at rates of reaction. Okay, and there's lots of different things that can actually affect rate of reaction, namely concentration, temperature, pressure, and of course a catalyst. Okay, along with surface area as well. We'll put that in there, why not? Okay, now what we need to do is start to quantify what effect these different things have on the rate of reaction. Okay, but really all we're bothered about here is concentration and how concentration actually affects the rate of reaction, rather than just saying, oh, well, if we increase the concentration of something, then the rate will increase. Okay, so what we need to do is start looking at this in a quantitative way. Now, an order of reaction is just a way of saying, well, this is the effect that it has in a quantitative way. Okay, now there are three orders of reaction that we need to concern ourselves with. Okay, the first one is zero order. Okay, you think we start with one, but no, we start with zero. Now what that says is that if a reaction is zero order with respect to a particular reactant, then it actually has no effect on the rate of reaction. Okay, so you can change the concentration, so square brackets representing concentration, has no effect on rate. Okay, so you can change the concentration of a reactant as much as you want and it doesn't actually have an effect. All right. The second, as you may have already guessed, is first order. Okay, now this is of course where a reactant does have an effect when you change its concentration. So the relationship between a change in concentration of something that has first order, okay, has a proportional effect on rate. Okay, so if you double the concentration of something, you would expect the rate of reaction to double. If you halve the concentration of something, you expect that to halve. If you multiply it by 3, the rate will multiply by 3, so on and so forth. So that's what proportional actually means. Okay, and then there's second order. Okay, like I said, there are only 3 that we need to concern ourselves with, and this is where a change in concentration has an exponential effect on rate. Okay, so you could double the concentration, the rate may increase 4-fold, okay, and so on and so forth. Okay, so what we've got is no effect on rate, a proportional effect on rate, and an exponential effect on rate. Okay, now the examples do like to show this in a graphical form, but equally, it helps us understand what's actually going on here. So a very simple graph. Okay, if I can draw a straight line, this is concentration against rate. Okay, so if I was to draw a zero order reaction, okay, or a reaction where it's zero order with respect to a particular reactant, then as long as I change the concentration, I keep increasing the concentration, but in actual fact, it doesn't matter how high the concentration is, then it has no effect on the rate. So what we see is this flat line here. Okay, I can double, triple, quadruple the concentration. It has no effect on rate whatsoever. So this is of course what we'd expect to see in terms of a concentration against rate graph for zero order. Now you're probably one step ahead of me. For a first order reaction, if it's a proportional relationship, it's got to be a straight line, hasn't it? So basically, if there's no reactant in there, then of course the reaction won't occur. So what we'll do is from 0, okay, we take a straight line straight up like that. If you double the concentration, you've doubled the rate. So of course the gradient might change depending on your scale here, but in fact it's a straight line. So this is first order reaction. So that's what we'd expect to see as we double one, the other doubles, and so on and so forth. And last but not least, you're probably ahead of me again, with an exponential relationship, what we see is an exponential curve here, and this is of course second order. Okay, so as we double the concentration, the rate might quadruple, and so on and so forth. Okay, so that's what we'd expect to see in terms of a sketch graph here, and they may give you a graph like this in an exam and ask you, well, from this graph deduce whether it's zero, first or second order with respect to a particular reagent. Okay, so what I'm going to do in the next tutorial is take a look at some data, some rate data, and how the different concentrations of different reagents affect the rate, and how we can use that to deduce whether the reaction is zero, first or second order with respect to each individual reactant that we're using in the reaction. Okay, so that's our introduction as to how we quantify now rate of reaction in terms of changing concentration of different reagents.